Hello students, following question is from part test 1 subject mathematics chapter probability and the question is asked for 1 mark. Question is, you have a biased coin that has a probability of 0.7 of coming up heads, that is probability of head is equal to 0.7, and your friend has a crooked 6-sided die numbered 1 to 6 that has a probability of 0.5 of showing the number 3. When rolled, each of the remaining 5 numbers are equally likely. You toss your coin and your friend independently rolls his die. The probability that you get a tail or your friend get an even number or both is dash. So such kind of questions we would solve in 2 steps. First steps would be defining the given events and its probability. Let me suppose that H is an event of getting head, whereas T is an event of getting tail. Both of these events are the result of tossing a coin. We are given that probability of getting head is 0.7. Also, we must know that head and tail, these events are mutually exhaustive. That is, probability of A plus probability of B would be equal to probability of my sample space, which is always equal to 1. And also in this case, head and tail, both these events are mutually exclusive. That is, probability of A intersection B is equal to 0. Or I can say that A intersection B would be a null set. In our case, probability of H intersection T would be 0. So using these 2 conditions, we can say that my probability of T would be equal to 1 minus probability of H, plus probability of T would be equal to 0.3, since my probability of H is equal to 0.7. Now let me suppose an event E, that is my friend getting an even number, which would be a result of rolling of a die. It is given that probability of getting 3 is equal to 0.5, whereas all the other numbers are equiprobable. Hence, again over here all these numbers are mutually exhaustive. Hence the summation of all this probability would give me 1, and the intersection between any 2 of these is 0, since they are mutually exclusive as well. So my probability of A1 would be equal to probability of 2 would be equal to probability of 4 would be equal to probability of 5, which would be equal to probability of 6, which is indeed equal to 0.1. Now probability of E, that is my friend getting an even number, which would be equal to probability of getting either 2 or 4 or 6, that is probability of 2 plus probability of 4 plus probability of 6. Since all these events are mutually exclusive, so we do not consider the intersection between any of these events, which would result from over here. I can say that this equation would be equal to 0.3. Hence I would say that probability of E is equal to 0.3, relation number 2. Once we are done this, we would move to step 2, that is getting our final probability. So our final probability would be either you are getting tail or your friend is getting an even number. So P of T union E is equal to P of T plus P of E minus P of T intersection E. And we are given that this T and E, both of these events are independent. Thus, for independent event A and B, we have probability of A intersection B is equal to probability of A into probability of B. Thus, we can say that my probability of T union E is equal to probability of T plus probability of E minus probability of T into probability of E. Now, if you substitute the value in this equation from equation 1 over here and equation 2, we would get our final answer as 0.51. So whenever such kind of questions are given to us, we will solve it in 2 steps. That is, first step we would define all the events and its probability, and second step get our final probability, which in our case is 0.51. 0.51. So my final answer is 0.51. Thank you.